Well, unfortunately, I wasn't able to finish that question on the other video, but let me just tell you that the other non-permissible is 4/3, and of course that comes from 3x minus 4, and we set that equal to 0, and we end up with 4/3. So there's the end of that page. If you want to turn over the page with me, what we're going to do now is just put this into practice with an application question. So before we begin, it's an area question, as it says, so we know that area equals length times width. And then what we need to look at is that they've given us actually the area equation. They've given us the length equation, and they're asking us to find the width. Well, that sounds pretty straightforward, so let's do that. And what we want to do is know that the width would equal the area divided by the length. So that's what we're going to do. The width is the area, and the area, of course, they gave us is 12a squared plus 25a minus 7, and we're going to divide that by the length, and the length was given at 3a plus 7. So in order to continue on, I need to factor the top, so I will do that. And my factors, I'm going to assume that you know what you're doing on factoring, so I'm going to give you 3a plus 7, and we have 4a minus 1. Underneath we have the 3a plus 7, and now that we have that, all I need to do is cancel out my factors. 3a plus 7, 3a plus 7, and I'm left with on top a 4a minus 1, and remember the bottom just became a 1, so we can ignore the denominator. That is the number of meters. Now if you want to have a look over here at this side, I'm just going to do this real quick. How did I get my factors? One more time, I'm just going to show this to you in case you need to look at this a little bit later. So I broke up the middle term, and I did 28a minus 3a minus 7, and remember that came from me multiplying those two outside numbers together, finding the factors, and I would then pull out what's common to the first two terms, and I'm going to pull out the -1, and I end up with a 3a plus 7. So my two factors were 3a plus 7 and 4a minus 1. You can have a look at that later if you'd like, but that's where this came from. All right, the next little bit is just saying if the perimeter of the field is 54, so what I know is that the perimeter answer will be 54, and then we want to determine the value of a. Well, here's what I've got. I have a length and I have a width now. So I have the length that was given to me, the width I just found, and I know that to do perimeter of a rectangle I need 2 lengths and 2 widths. So that's what I'm going to do. I'm going to throw a 2 out in front of the length, which is 3a plus 7. That comes from the question. I also need 2 widths for a minus 1, and that all should equal 54. I will use FOIL and go through the bracket to expand my brackets, and then I'm going to collect my like terms, and that gives me a 14a, and I'm going to put the actual numbers over on the other side so I can actually solve for a. If I divide both sides by 14, I will get a number of 3. That is a, which is what they asked me for. Then finally they said, hey, if the field has to be treated with fertilizer and it costs $2.40 per square meter, what is the cost? Well, it goes back to the area. I need to know what the area is. They gave it to me as 12a squared plus 25a minus 7. Now that came from the question. They told me the area. I also was able to find a. So now that I have a, all I need to do is plug my 3 in for any time I see an a. So I'm putting 3 in for a, And then I just can go ahead and calculate that. So I'm going to end up, after putting all those numbers together, I should get 176 meters. Now that just gives me my total area, my actual number. I need to calculate the cost. And the cost, they said, was $2.40 per square meter. So if I have 176 square meters, I'm just going to multiply that by $2.40. And when I do that and put it into my calculator, I end up with $422.60. And there is the answer to that question. You may want to stop and restart this, but because I did probably go a little fast, but it's just really very straightforward, but have a look at it. I just have two other questions that I need to run past with you, and that is this, just a couple things that will help. The first question says that simplify. I look at the first question. I don't see anything that I can do to simplify it, but I do need to say what my non-permissible values are for x in terms of y. So I look at the bottom and I know that x cannot equal y, because if it does, then I'm going to get a 0 on the bottom. And then that is all I can do with that particular question. The second question, I am going to simplify if I can. Now, of course, the top, there's nothing I can do. But the bottom, I can go x minus 5y and x plus 5y because it's difference of squares. Look at this. I'm going to grab it. I read these cancel out, these factors. And I'm left with a 1 on top because there's nothing left, so that means it's always a 1, and the x minus 5y. That's the answer. Non-permissibles, I look and I say, hey, x cannot equal, and I look at these, and that would be 5y. And I think that is what we've got. Actually, it looks to me like it could be a plus or a minus 5y because it needs to take into account this x and also this x. So a plus or a minus, if you can squeeze that in. And then finally, this question over here, we're going to do the same thing. We're going to try to simplify it. I'm going to do it like this. I'm going to take my bracket and I'm going to expand it so you can see my x plus y, x plus y. Now, why would I do that? Normally, I don't like to do that, but I'm going to try to factor and cancel out my factors. So if I can display them, it'll make it a little easier. My bottom, I'm going to pull out the 3. So I'm going to end up with an x to the power of 4 minus y to the power of 4. I've just pulled out my common factor. I've run out of room, so I'm going to go down below. And the next step I'm going to do is I have to continue factoring my bottom, my denominator. So the top's going to stay the same, x plus y, x plus y. But on the bottom, I have difference of squares. If you notice this, we have an x to the power of 4 minus y to the power of 4. They're both perfect squares. So I'll put my 3 down, and then I'm going to go x squared minus y squared. And I'm also going to have an x squared plus y squared. Now, knowing that, I look and I say, hey, but this is also a difference of squares. So I'm going to have to go one more step. I have to include my top first. Not touching the top, I'm just rewriting this. X plus y, x plus y. And along the bottom, I'm going to have a 3. Now, the yellow, x squared minus y squared, is a difference of squares, so I'll go x minus y, x plus y. And now recognize that my x squared plus y squared, I can't do anything with. That's not a difference of squares because there's a positive sign in between. So I just leave that the way it is. Now that I have that, I can start canceling. So I have an x plus y and I have an x plus y. Is that it? Well, I can also look at my whole numbers out front. I have a 6 and a 3. I know that 3 goes into 3 once and I go 3 into 6 twice. So I can simplify those front and whole numbers. what I'm left with is a 2x plus y, and on the bottom I have an x minus y, and I have an x squared plus y squared. Now, the last thing I need to include here is my restrictions. And so what I find is that I look here and x cannot equal y, because if it does, it's going to become 0. But I also noticed that up here I had a plus and a minus in the brackets. So I need to include, I'm going to actually erase that and go plus or minus y. So this is coming from this step. Let me use like blue. This step and this step, I'm looking and saying, hey, if x becomes a y here, then it's going to be 0. And if x is a negative y here, it's going to be 0. So that's why I have to include both the positive and the negative. All right, that is it. Go ahead and do these questions that are assigned to you. That's it for the day, and you should probably get those done hopefully by the end of the class, and if not, for tomorrow. That's all.